Okay, hello everybody. We are looking at some things from section 4.1, radian and degree measure. I'm here live with block 2. Block 2, you want to give a shout out? All right.
We have 2 shadows.
And we have 2 shadows with us today who are also learning about trigonometry today. Okay, so you already watched a series of videos to start off this section. So I just want to kind of recap. You know, like, I don't know, they used to do like the fastest 2 minutes in sports or something like that. Do they still do that?
The 2-minute warning.
Well, no, but like it was like on sports. Anyway, so here's like my 2-minute recap of what you hopefully gathered from the videos. All right, this was just a little introduction to what trigonometry is. You learned about angles and how in trigonometry they have motion, right? So there's an initial side that is always here on the positive part of the x-axis, and then an angle can rotate, you know, in a counterclockwise direction, which would be positive, or it can rotate in a, what happened here? Or it can rotate in a clockwise direction, which would be negative direction. So that was all on the video, positive angles, how we name angles. We talked about coterminal angles. So coterminal angles have the same initial side and the same terminal side, but you might get to them in different ways. All right, that's coterminal. Then we talked about, on the videos, 2 different units of measure for angles, radians and degrees. And I think from the Khan Academy video, I thought that was a pretty good video. Except for how he kept saying radiuses. That was kind of a...
I was like,
yeah, well. All right, so the idea with a radian is if you have a circle with a certain radius, we'll call it R, and you have an arc length. Yeah, that's not gonna flex. Okay, let me back up. So this is a radius, and then there is some arc that's formed, right? And if that arc, which we call arc length S, if that arc length happened to be the same length as the radius, then, you sure can. It's in Preston? Oh, yeah. It's okay. It's always in Preston. What?
Yeah, I need it for a quiz.
Good, then I need your phone.
Yeah, that's fine.
Uh-oh. Do I have one I can read? Okay. We're recording a video and everything. Okay. All right. Sorry, we were interrupted. Okay, so this arc length here is going to be represented by S, and then we have this formula that relates the angle, theta, the radius of the circle, R, and the arc length. But what's interesting to note is if you have a circle, okay, and you have radius, and let's say you have the radius here, and if we cut off, and if we formed an angle so that the arc length here is also the same length as the radius, then that angle right there is defined as 1 radian, okay? So that's formed. A 1 radian angle would be if the arc length is equal to the radius. Okay, this one might be, I don't know, this may be, what if S here was 2R, right? That's R here, that's R here. Then this would be 2 radians long. All right, again, I'm trying to do my fastest 2 minutes recap. So what else did you learn? You had the formula for the circumference of a circle is 2 pi r. Because C equals 2 pi r, a central angle of 1 full revolution corresponds to an arc length of S equals 2 pi r. So what is the numerical value of 2 pi? Okay. Was this on the video?
Yeah.
Yes?
No, maybe not. It was not.
I feel like we learned this in the podcast.
Maybe.
Yeah, it's not a
Yeah.
In Khan Academy?
Yeah.
So if I had that picture where this was R, this was R, this was R, this is 1 radian, right? This angle's 1 radian. So how many radians would it take to get all the way around the circle? And the point is, it would be exactly 2 pi, which is about 6.28, right? To get halfway around the circle would be pi radians, so it would be 1 well, like here's an R, here's an R, here's an R, and then there's a little bit extra. Does that make sense? So it's like 3 complete radiuses and then a little bit extra. So all the way around, that would be like 3.14 of those radius lengths, right? Which is pi, right? Okay. All right, see figure 4.6 on page 283. They did a nice job on that picture on page 283 to show what's going on. They're showing 1 radian angle, 2 radian angles, 3 radians. They're showing that little extra bit, and if you're trying to get all the way around the circle, it's going to be a little bit more than 6 radians. As a matter of fact, it's going to be closer to 6.28 radians because it's 2 pi all the way around. Are we okay with this? All right. So 1 revolution is 2 pi radians, right? If I go all the way around the circle, that's 2 pi radians. So if I only want to go halfway around the circle, like from here to here, that's how many radians? Pi radians. Was this on the video?
Yeah.
And a quarter of the revolution would be 1/2 pi. So we'll write that as pi over 2 radians. All right. This was on the video, I know this, right? This is talking about if your angle, for example, ends up in quadrant 3, the terminal side in quadrant 3, then your angle must be between what and what? 0 and pi over 2 is here in quadrant 1, but here we'd be between pi and 3 pi over 2, right? So if you didn't get that, you might want to rewatch that video. Coterminal angles have the same initial side and the same terminal side. To find a coterminal angle, you're going to add or subtract multiples of 2 pi. These examples were on the video, correct? All right, of how to find coterminal angles. 2 angles are complementary. Was this on the video? Yes. So 2 angles are complementary if their sum is pi over 2. 2 angles are supplementary if their sum is pi. There was examples of that on the video. And then, was this on the video? One of the videos that you watched, degree measure?
That was the 4th video.
Yeah.
This is the 4th one?
Yeah.
Okay, so we should just kind of take it from right here?
Yeah.
Okay, so degree measure, 1 degree is 1 over 360 of a complete revolution. That means 360 degrees is equal to 2 pi radians. 180 degrees would be equal to pi radians. So if we want to convert from radians to degrees or vice versa, we're going to use that relationship, that 180 degrees is equal to pi radians. All right, so to convert 2 radians, you're going to multiply the degrees by pi over 180 degrees. All right. See you later. Have a great day.
Bye.
Bye.
So let's take and if we're going to convert radians to degrees, then we're going to have to multiply by 180 degrees over pi. All right, so let's take a look at an example. We are going to express each of the following angles in radian measure as a multiple of pi, and we are not going to use a calculator to do it. So if we want to convert 60 degrees to radian measures, we're going to multiply, and I'm going to multiply like this. I'm going to say I want to multiply by pi radians over 180 degrees. Everybody agree that that's like a unit fraction, like 12 inches over a foot, right? Or 1 hour over 60 minutes, right? Those are unit fractions. So here's another unit fraction, pi radians over 180 degrees. And I would write it this way so that my degrees divide out, right? And I'm left with just radians. And I can also say, 60 goes into 60 once and into 183 times. So I'm left with pi over 3 radians. Okay? So 60 degrees is the same thing as pi over 3 radians. Are we okay with this?
Yes.
All right. Let's try one more of those. Let's do 320 degrees. Again, we're going to multiply by pi radians over 180 degrees. The degree symbols are dividing out, And we're left with, let's see, we can divide, does 20 go into both of those?
Yeah.
So 20 goes into 189 times, is that right?
Yes.
And 20 goes into 320, 16, does that sound right? 16 times? So we end up with 16 pi over 9 radians. Are we okay with this? All right. What if, I'm going to skip that last one, what if we want to go the other direction? Express each of the following angles in degree measure. Do not use a calculator. So for these, let's multiply by, not by pi over 180 degrees, but this time let's multiply by 180 degrees over pi. Okay? In this case, and really this is 5 pi over 3 radians. So the radian units are going to divide out, and the pi's can divide out. And so, and 3 goes into 3 once and into 180 60 times. So I get 5 times 60 is
300
300, what units?
degrees.
300 degrees. Are we okay with this?
Yeah.
All right. Okay, so that's how I would do those. Let's do one more of those. So if I want to convert 3 pi radians to a certain number of degrees, I'm going to multiply by what?
180 degrees over pi.
180 degrees over pi radians. The radians are dividing out, the pi units are dividing out, and we get 3 times 180 is,
540.
thank you, sir, 540. What units? Degrees. Are we okay with this? Awesome. All right. What if I want to convert 3? Because if you don't see a degree symbol, it's understood to be radians, right? So this is 3 radians, and I want to convert that to degrees. I still have to multiply by 180 degrees over pi radians, correct? So the radian units are dividing out, and we end up with 540 over pi. Does that look right? 540 over pi degrees. I mean, they didn't want us to use a calculator, so we're not getting a decimal approximation for it, but we could. I mean, if we take 540 divided by 3.14, you would get your approximate number of degrees. That's equivalent to 3 radians. And I know that back in our picture, let me just draw a new picture. And I know that from our discussion earlier about what 3 radians would look like, I know that there's 1 radian, like here's 2 radian, you with me? Here's 3 radian. Remember we talked about how it's going to be almost all the way, right? So 3 radians, I'm going to guess that's going to be maybe 170 degrees or something close to 180. Does that make sense? Okay. Taking pictures. All right. Okay. Angles can be measured in finer units than degrees. So these symbols here mean, this means obviously degrees, right? But this means minutes. And this symbol here means seconds. Just like on a clock, like hours, minutes, seconds. This would be degrees, minutes, seconds. So there are 60 minutes in 1 degree. Just like there's 60 minutes in 1 hour. And there are 60 seconds in 1 minute. Just like in time, time, right? So this, if we want to convert 48 degrees, 15 minutes, 24 seconds into decimal degrees, right? We're going to convert decimal degrees to minutes, to degrees, minutes, seconds, and vice versa. And we're going to use our calculator to do this. Okay, we could learn how to do it by hand, but we have the TI Inspire, so let's use that. All right. Yikes. I need to pause for a brief momento. Okay, so we are back, and we are going to be converting, and you can't see anything, can you? Okay, and we are going to be converting 48 degrees, 15 minutes, 24 seconds with our calculator into decimal degrees. So grab your calculator, and we're on a calculator page. And by the way, can we all make a pact right now that we're going to keep our calculator in radian mode, not degree mode, okay? Does it say RAD up at the top of your calculator right now? If it says degree mode, let's talk about how to change that, okay? But I need a little screen here. No? Class, no, documents. Here we go. So if I go to the home screen and I go to settings and I go to document settings, everybody with me?
Yeah.
And it should say radian. If it doesn't, can you change that at this time? All right, and then say okay, or you can say make default. All right, okay, so now back to our work. We were going to a calculator page. All right, and we are converting, I already forgot, it was 48, 15, 24. Okay, so we're doing 48. And remember, we're in radian mode, so we have to tell it that we want degrees. So we're going to push this little question mark button down here at the bottom, and we're going to push the degree symbol. So that's 48 degrees, and then was it 15 minutes? 15, and I want minutes. I got to go back to that question mark button, and I got to push this little button. It's going to represent minutes. And then I want 24, was it 24 seconds? Okay, and I've got to push that question mark button again, and this time, no, don't use this one. You got to use minutes twice. Minutes twice to be seconds. Okay, so now I want to, I think that's used as like quotes or something. I don't think, you know, it is weird. Okay, so now we want to convert this to decimal degrees, so I can predict it's going to be 48 point something degrees, right? So let's go to the book, this book button, which is 2 buttons away from the 9. And I'm going to just push the letter D to get, these are all the different options, apps, if you will. And I'm going to push the D so I can start with the D options. Oh, there it is, DD for decimal degree. And I push enter and saying, oh, do you want to convert this to decimal degree? Why, yes, I do. And I get 48.2567 degrees. Are we okay with this? All right. Questions on this?
I have syntax error.
That is so rude. But all right, let's see. I'm going to pause and okay. Now let's try going the other direction. This time, let's try converting 36.524 degrees into degrees, minutes, seconds. So I'm going to push the degree button to say I want 36.524 degrees, but this time I want this in terms of 36 degrees, some number of minutes, some number of seconds. Rachel? I just made that one up. I just made that up. All right, so I'm going to push the book button, and this time I want to go to the option that says, there it is, degree, minutes, seconds. DMS, degree, minutes, seconds. It says, oh, you want to convert this to degree, minutes, seconds? Why, yes, I do. And I get 36 degrees, 31 minutes, and I guess it turns out to be 26.4 seconds.
So cool.
Are we okay with this?
All
right.
All right.
All right, block 2 is really loving this. Okay. All right, so back to our notes. We did that example. Okay. So let's take a look at this. Remember, we have this formula, theta equals S over R, which relates the radius of a circle, call it R, to a certain arc length, call it S, to the angle that's formed, call it theta, right? This is our formula that relates theta, S, and R. So in this example, we're trying to find the radian measure for this angle theta. All right? So if we're using theta equals S over R, tell me what am I gonna plug in for what? Theta is gonna be equal to what, Garrett?
12/6.
Yes, theta equals S over R, so that S is 12, that's our arc length, is 12, so that's our S, over the radius is 6, so it's just equal to
2.
2. What units are we talking about?
Centimeters.
Minutes.
What? Degrees.
Second.
I'm hearing all sorts of things from block 2 right now.
Degrees.
The correct answer is radians. So this is theta is equal to 2 radians. This formula, hang on, this formula only works if theta is in radians. It will always be in radians for this formula, okay? The S and the R are always going to be in the same linear unit. Like in my example, they were both centimeters. So in this, S could be centimeters and R could be centimeters. S could be feet, R could be feet. S could be kilometers, R could be kilometers. But theta is always going to be radians. Are we okay with this? All right, let's see if I got another example for you. Find the arc length here. All I know is that I want theta to be this angle, and the radius here is 4. So we're going to be using our formula, theta equals S over R, but this time we're trying to find the arc length. So what can I plug in where? Dave?
You could do theta equals S over 4.
Okay, so theta is equal to S over 4. We're trying to find the arc length, so what are we trying to find, theta or S? S is the arc length, and so I can multiply both sides by 4, but do we know this angle, theta? I get S equals 4 times theta, but what's theta? Look at my picture.
Oh, it's 180 degrees.
So am I going to plug in 180 degrees?
No.
No, because this formula only works for what? Radians, so I better not plug in 180, I better plug in what?
Pi.
Pi radians. So S is equal to 4 times pi. What units are we talking about now?
No, inches. No, degrees.
Don't change your mind, Dane.
Inches.
Inches. Remember that the units for these units will always match, right? The S and the R units will always match. The radius was given in terms of inches, so the arc length is going to be 4 pi inches. And if you want a decimal approximation for that, 4 times 3.14, I don't know, it's like 12.2 inches, something like. Does that make sense?
Yes, ma'am.
I just made that up, but it's something like that. All right, questions on this? Okay, so arc length for a circle with radius R.
I think Julie had a question.
Oh, I'm sorry, Julia.
It's a very general question.
Yes.
So in the beginning of it, we learned about like alpha, beta, theta. Why are we only using theta?
Theta is used, I would say, 99.9% of the time.
So we could be using alpha and beta.
Yes. We're just naming angles with your favorite Greek letter.
Okay.
But mathematicians prefer theta as the Greek letter of choice. Okay. Arc length for a circle with radius R, a central angle theta, intercepts an arc with length S, given by S equals R theta. This is not a new formula. That's the same one as theta equals S over R, just multiply both sides by R, right? Same formula. So let's take a look at this example. A circle has a radius of 27 inches. Find the length of the arc intercepted by a central angle of 160 degrees. All right. Hint, big hint, convert to radians first. Why do we need to convert to radians?
Because it doesn't work unless theta.
The formula does not work if it's not in radians. So go ahead and convert first. We're doing 160 degrees. How do we convert that to radians? Multiply by pi over 180 or 180 over pi? Pi over 180. So degrees divide out, and 20 goes into both of these? Yes? 20 goes in this 9 times, 20 goes in this 8 times. So we get 8 pi over 9 as this angle. So we're not going to write it in degrees. We're going to say it's really 8 pi over 9 radians. Agreed?
Yes.
So now we're going to go to our formula. We're trying to find, what are we trying to find? The arc length? So we can use this formula, or we can multiply both sides by r and use this formula, right? So we get S equals r times theta. What am I plugging in for r?
27.
What am I plugging in for theta?
8 pi
8
over
pi
9.
over 9.
8 pi over 9, and so that's going to give us our arc length, I don't know, let's see, 9 goes into 9 once, into 27 3 times. I'm getting 24 pi. What units are we talking about?
No,
Inches.
inches.
I hear radians, I hear inches.
Since we already have radians, it's the length.
Arc length is going to be a linear unit, and it's always going to match the radius unit. Okay, so if the radius was given in inches, our arc length is going to have to be inches. So it's 24 pi inches. Are we okay with this?
Yeah.
All right. And if you wanted to get a decimal, you could do 24 times 3.14159, whatever. All right. Okay, I think that's probably a good stopping point. Let me just give you a preview of what's to come. Hang on. Preview and what we'll have to learn on Tuesday and for block 7 and 8 in another video. Linear speed and angular speed is what we're going to talk about next, and some good real-world examples of that. And then we talk about area of a sector of a circle. And that's it for the section. All right, so we're almost through, but there's a lot of good stuff in this section. All right, so that's it for this video. Thanks for watching.